Welcome to the Brain Health Revolution podcast with your hosts, Aisha and Dean Sherzai. Dean and I are very excited to be here today with you all. And the topic of today's discussion is about the alleged fabrication in Alzheimer's research and the recent articles that have been published around the topic. But before we take a deep dive into this interesting conversation, I wanted to take a few moments to advertise our Neuro Academy platform because we believe so strongly in the concept of brain health in a community setting. I would like to invite you to join our Neuro Academy, which is an online community. It's membership-based environment outside of social media, where you will have access to multiple evidence-based on-demand courses and engage with a thriving and a supportive community of people on a journey towards better brain health. You'll be connected with us, two preventive neurologists and lifestyle specialists, as well as a team of moderators who will guide you. With your monthly or annual subscription, you will have access to monthly live Q&A sessions, live cooking sessions, live podcasts and Q&As with remarkable health leaders, ongoing on-demand courses on lifestyle, nutrition and cooking, neuro coaching, anxiety, and so many courses on various topics related to brain health. You will be able to get continual education, CE, CME credits if you're interested, and also receive certification after taking courses. You'll get everything you need to achieve optimal health, a better, sharper memory, and prevent cognitive decline. You can join us by visiting neuroacademy.com. Thank you so much for your time.
This is a very interesting concept, a very interesting piece of information that came to us. It's quite controversial if it turns out to be true. First of all, before we even go any further, the allegations have been raised. There seems to be some consistency in the data against the people that have been accused, but that has not been corroborated, has not been validated. It's still being investigated by the governing bodies and the university and the publishing journal and system. So we have to wait for that. But nonetheless, there is some inconsistencies. And before we go any further, I want to kind of get us reoriented. Whenever there's controversy in science, even if it's supportive of our perspective or against our perspective, we really have to speak to the greater science, because whenever people find a weakness or an error or a fabrication, they attack science. That couldn't be further from the truth. Actually, it's the strength of science, because scientific methodology has a method that you can follow. And even if somebody fabricates it, you can actually identify the fabrication in the same scientific methods that actually created the fabrication. So that's the strength of science, where you follow the data. You make sure that the data is valid. You make sure that the way the data was captured, arrived to, analyzed, processed is reproducible, validated, and others can reproduce them as well. And then you can say it's reality. It's a beautiful system. It's not a perfect system, but it's a beautiful system. And it doesn't speak to the weakness, but it speaks to the strength of the science. But nonetheless, after all of that, having said that, I would have to say that this is, if it turns out to be true, this is going to be a major cataclysmic change in the science around Alzheimer's.
All right, so let's tell our audience what this is all about, because some people might actually not have heard about this. So recently, on July 22nd, I believe, 21st of July, an article was published in Science, which is a very, very popular online and in-print magazine that talks about the latest in the world of science.
Extremely high impact score, which means that it's looked upon as a very valid, highly validated and respected journal.
Exactly. And it also, it has the public side where articles are published for the general population. Yeah. And it also has a scientific journal where researchers actually publish their papers. And it has multiple different segments. There is a general science magazine, and then there's immunology, there's robotics, there's signaling, translational medicine, etc. So this was published in the General Science magazine, and the title of the article was Blots on a Field. So it's a question. And the subtitle said, "A neuroscience image sleuth finds signs of fabrication in scores of Alzheimer's articles, threatening a reigning theory of the disease." And essentially, I'd like to take some time to kind of just go over this article for some of you who haven't read it. And Dean, maybe you can actually expand on some of the sections. So an investigation was started in August of 2021, and a neuroscientist and a physician, Dr. Matthew Schrag, who we actually have the pleasure of knowing, he trained as an MD PhD in Loma Linda University, and he was such a brilliant medical student when I was a resident there. And now he's a physician and a scientist at Vanderbilt University. According to the article, he got a call from a lawyer or a legal team, and that essentially started this huge maelstrom of possible scientific misconduct. A colleague of Dr. Schrag's wanted to connect him to an attorney investigating an experimental drug for Alzheimer's, which is called Simufilam. Am I pronouncing that right?
Sounds right.
Right. And so the drug developer, the pharmaceutical company, was Cassava Sciences. It claimed that it improved cognition, and it did so by repairing a protein that can block sticky brain deposits of the protein amyloid beta. And amyloid beta protein has been the hallmark of Alzheimer's disease pathology and the main focus of research for many, many years. I would say decades, correct?
Actually, from the very start, when Alois Alzheimer's in the turn of the century, from 19th to 20th century, actually discovered the first case of Alzheimer's and then looked at the pathology in the brain and identified amyloid.
Right, exactly. All right. So the attorney's clients were two prominent neuroscientists who are essentially somehow affiliated to the pharmaceutical company's stocks. They believed that some research that related this particular medication may have been fraudulent. So Dr. Schrag was asked to look into it and to report to the legal team and the neuroscientists what the deal was. Correct. And so after Dr. Schrag started looking into the data and he looked further into the source of the information that led to this research, he found some problems.
Absolutely.
And specifically speaking, one of the most important seminal papers that directed this line of research that was published in the Journal of Nature in 2006, according to Dr. Schrag, the images that were published there were flawed. And this particular influential study was done by some scientists from the University of Minnesota. And Dr. Schrag initially found that some of these images were essentially not representative of the true data, and that several of these images were essentially either, this is allegation, that it was essentially copy pasted. And there were a lot of errors that he found out. So he reported that to the legal team, but he also became essentially a whistleblower to this research, and he reported it to the NIH. And this is a serious allegation because since then, millions, if not billions of dollars have been spent on this particular line of research.
What do you mean by since then, you mean by the time, since the paper was
Since
originally
2006.
published in
Correct.
2006, and it has directed research ever since.
That's right.
The idea that amyloid might be involved or might be causal or to Alzheimer's is not new. It's been, like I said, for decades. And ever since we've found out that amyloid was potentially not causal, but strongly correlational, we've been trying to do different things in order to reduce its production, whether by affecting the enzymes that produce it, whether it's to directly attack amyloid itself or create antibodies against it. And this paper in 2006, which looked at the imaging, pathologic imaging, really strongly influenced the science to push that concept even further, the
Yeah.
amyloid model
Right.
of Alzheimer's.
Right. So, this was a 6-month investigation by science, and it was corroborated by some other top Alzheimer's researchers as well. The names have been published. This was Dr. George Perry from University of Texas, San Antonio, and Dr. Forsyth from UCSF, University of California, San Francisco, who reviewed Dr. Schrag's findings at Science's request. And they also concurred with his overall conclusion that there were several images that were shockingly blatant examples of image tampering. And basically, I'm actually reading some of the article lines just to make sure that I'm accurate. The authors appear to have composed figures by piecing together parts of photos from different experiments, says Elizabeth Bick, who is a molecular biologist and a well-known forensic image consultant. Quote, the obtained experimental results might not have been the desired results, and that data might have been changed to better fit a hypothesis, close quote.
If that turns out to be the case, it's just remarkable that this is not an accidental thing. This was, if true, an active process of fabricating, taking parts of image that did not support their hypotheses and finding other images that actually did and superimposing it on it. And that would be absolutely devastating. Definitely to the scientists, which would probably lose their grants, they would lose their positions, as well as all they've been asked, if true, that they would also be responsible for giving back the money. Well, at least the universities would, and that would, and that's not as bad as the fact that science would have been misdirected for decades in the wrong direction. Mm-hmm. This is not new. There have been cases of scientists fabricating and recreating and falsifying data. There are many, many cases of this. And there are a lot of cases of them being caught and then face the consequences. But always what it does more than anything else, maybe in the short term, it gets the scientists the grant that they wanted, and the notoriety that comes with it. But in the long run, it profoundly affects the science and all the people that suffer from the disease that you're looking at, be it Huntington's disease, be it Alzheimer's disease, be it MS, multiple sclerosis, or any other disease. Anything that misdirects science for a few years, its consequences are suffering of the patients for that many years that could have been going in the right direction. The science could have been going in the right direction. So that's why we are very, very interested in the outcome of this, because we are in Alzheimer's research.
Absolutely.
And we've been talking about alternatives now.
And our patients are looking for hope and for treatment too. So how does this affect the current research that is being done in simufilam? So essentially, this medication is targeting amyloid beta protein, or at least the filament part of amyloid beta protein. And if the theory behind the mechanism of action is flawed, then the medication is of no use, and all this money being spent is essentially being directed in the wrong side. Is that the case, Dean?
Yeah. I mean, the audience knows that for decades, you and I have been talking about the fact that if amyloid is a pathway, and we're kind of incredulous about that as being a major pathway. There's some evidence that there are a group of Alzheimer's patients that are definitely driven by amyloid and tau, to be exact, those two proteins. And we've talked about the 3%, the presenilin 1 variety, presenilin 2 variety, and APP that are really strongly driven by amyloid and the amyloid process, and maybe even some of the other ones. But we think that a great number of the rest of the dementia cases and Alzheimer's cases are driven by a more complex picture. Mm-hmm. And we don't know what that number is going to turn out to be. And we're not here, wringing our hands saying, look what we've been talking about. See, we're right again. We really are not. We just want the science. And even if it meant that 20% would be cured with a pathway of amyloid, that would be huge. In the United States alone, 6.5 million people suffer from Alzheimer's. That's 20% of 6 million. It's remarkable.
It really is.
1.2 million people or more. So we definitely don't wish for science to fail, but at the same time, it's critical that the correct science goes out so that people are not misdirected. And at least in the case of amyloid, we think there's an extremely high over focus on one molecule. And in fact, for the last couple of decades, it's been singularly amyloid model, and everything has been thrown at it and everything has failed. And we think that some research should have been done in other directions, not just tau, but also in the directions of lifestyle and diabetes and insulin resistance and cholesterol and high blood pressure and all the other cumulative effects of aging and or poor lifestyle or environmental factors that could be contributing and starting this cascade that ends up in Alzheimer's and other dementias. But it was remarkable that how singular-minded we have been when it comes to Alzheimer's. It's been amyloid or nothing.
Right.
And even when the data was pretty strong on some of the population and a tau model later on in the disease, even that took a while to take a hold because amyloid was almost like, I don't want to sound bombastic, but amyloid was king.
Yeah, absolutely. I guess just kind of going into a little bit of detail for people to understand what, how much work it actually took for the researchers to make sure that these allegations were not taken lightly. And the kind of images that they were focusing on and investigating are called Western blots. And you and I wanted to kind of give our audience a bit of an idea of what that essentially is. So it's a lab technique, and it is used to detect a specific protein in blood or tissue sample. And essentially, they use a gel electrophoresis, and through that process, they're able to separate different kinds of protein. And it just spreads on a gel surface based on its size, based on some other characteristics as well. And in that paper, and as this has been described in the Journal of Science, they found multiple different similarities and errors. And so the scientists, specifically Dr. Schrag and his team, they contacted multiple authors and multiple journals because it's not just one paper that described it. Several other papers that came from that particular seminal paper also based their information on those images.
It was one of the most cited papers since 2006.
Agreed.
Which means that when a paper is highly cited, means that other research projects are based on that paper.
Right.
Other conversations are based on that paper. Other proposals and grants are based on that paper. And so the sphere of influence was profound. And that's why this is so controversial.
Exactly. And so we're still waiting to hear from the primary author, who I probably will butcher his name, but Dr. Lesney from University of Minnesota, and his colleague, Dr. Ash, who touted this particular protein, the A beta star 56 protein, as a very important element in the brain tissue of Alzheimer's patients or Alzheimer's disease models. They were done on animals, essentially. So nobody's heard from them as of yet, and this conversation is still brewing, and we're still waiting to hear from the parties involved to see what the next steps are. The investigators didn't have access to the raw data, only the ones that have been published. Is that a problem?
It is. I mean, because you need the raw data to know that the inconsistencies that you're seeing are true inconsistencies or not. If you don't get the raw data, you can still, with a great deal of strength from the analysis, say that there's a strong likelihood that this is false. But it would be much easier to validate, if it's true or not, or negate if you had the raw data, because but that's what we're waiting for. I want to make sure that we again expand on the concept that this is something that is seen in science. It's not a weakness of science. But it's also the origin of this kind of error comes from the fact that there's so much pressure on some of these scientists,
That's true.
ourselves being some of them, to live from grant to grant, from funding to funding.
Right.
And they say publish or perish. And if you and it's not just publish or perish. Publish in a high impact journal or perish.
Right.
You know, if
That's
you don't publish in Science or in Nature or in Cell or, you know, one of the big journals, or JAMA or New England Journal, which have very high impact, you're not going to get grant funding. Because at the end of the day, NIH, which is a major source of funding, or National Science Foundation, or some of the foundations, they have a couple of things to rely on as far as, you know, whether to give their money or not. One is the location of where the science is being made, because that tells you whether the science can be done there. I mean, if somebody comes from their garage and says, I can do some major research, this is not the early 1900s where Edison did most of his work from his garage, which then turned into a huge factory, but laboratory. But now you need a major environmental support, community support, university support. So the university name, the location does matter. The second thing that matters is your record of publication and research. And that's where the pressure comes in. You have to publish regularly and publish in high impact journals. And then ironically, thirdly, is the idea, because a lot of people have great ideas. We're talking about hundreds of universities around the world now. It's no longer just Yale, Harvard, and Columbia, and, you know, Stanford, and a couple of other places. Now you have 1,000 universities in the United States doing amazing work, and that's not all. South America, Europe, some of the greatest research we've seen is in Italy and in, you know, and Sweden and other places, and now China as well, and India. So the competition is fierce, and if somebody's under pressure to publish, they might be forced to fabricate. Not us. We fight for the good fight. For that's why we took the path less traveled, which is focus on prevention, which was not popular at all. If you're not doing some kind of molecular work where it moves one, enzyme or one molecule, or blocks one pathway, it's not going to be funded. So the pressure should be addressed. The mechanism of analysis should be addressed. How a paper is published and how others look at it should be reviewed again. But after having said all that, I mean, right now we get hundreds of thousands of papers published every year. Who's going to do all of this?
Right. So I think as you and I have talked about this, you know, the Swiss cheese model of how errors are caught, and whether it's in health or in the realm of research and publication, hasn't really been stabilized. There's a lot of subjectivity, and the Committee on Publication Ethics, you know, has to actually step up to make sure that there's somebody who can keep an eye on image manipulation or data manipulation per se. You and I have seen that, you know, for some journals that are on the lower impact, which means that, you know, they're basically accepting anything and everything that is out there. They don't have a lot of reviewers who spend enough time to make sure that the data is checked and that there is an oversight of what is being published. Whether it's image integrity standards or data integrity standards, that's something that has to be improved, regardless of what journal it is. How do we do that? I'm not sure at this point.
At the end of the day, we're humans. We have human systems. And human capacity to lie and falsify is there as well. But at the same time, the integrity of scientists is something that we've counted on for a long time.
Agreed.
The other thing is reproducibility is another factor that should be looked at. Whenever somebody comes with a result, we should take the time to see if others who are not invested in the same concept can reproduce the results as well.
Right. And also I think it would be important for like most journals do, I think the raw data should be available.
Absolutely, yeah.
A lot of journals actually publish their supplemental data, which includes the raw data, so that if somebody wants to perform a meta-analysis or even further analysis on the data, it can be made available. So I agree that there are ways to improve that. I do agree with you that the most important thing is for us not to lose hope, and it's pretty sad to see some statements that are being propagated about this particular news. Things like you can't trust science or we've been lied to and things of that nature. I think that's a bit extreme. There are a lot of phenomenal scientists and physicians and doctors who are doing such amazing work, and like you said, human error happens. And the fact that we're all talking about this, and the fact that this news has come out on Science, and everybody's stopping the research and they're going back to see what led to this, in itself is hope.
Absolutely.
And it's a positive thing. And it's not, directing fingers at anyone, but essentially improving the mechanism to do more ethical research and to find answers for very difficult questions.
I mean, science is one of the areas that, as much as people think that we're investing in it, actually it's not as highly invested in as some of the other areas of our life. And the big picture, it's actually probably the most important area, because it's improving our health, it's improving our system. Science is not just medical science. We're talking about everything around us has to deal with science. So there should be greater investment in systems of science. For example, when you're publishing, you send your papers to journals, and if it's a high impact journal, that means they have their own money, they have their own investigators that can actually peer review, they're not influenced by others, and so they are really out there to hunt for bad science, and that's actually the way it should be. But a great majority of journals don't have their own peer reviewers, so they ask the very person that's actually giving them the paper, the research to be published, they're supposed to provide their own reviewers. So there's a bias already. If there is more funding towards a proper review process, a more open journal evaluation system, a more open system of publication, so general public can get a eye on the data as well. Then there's greater transparency, more eyeballs, less likelihood of fraud slipping through, data being transparent. I mean, of course, we know that some of the data has to be protected because of the legal issues and ownership issues, but nonetheless, a great deal of research doesn't have those limitations, and it should be open to the general public, and that's where funding comes in.
And especially if it's de-identified, so people
exactly,
don't hurt,
exactly. De-identified meaning that the name of the people, and so that HIPAA compliance is maintained, that nobody's threatened as far as their information being revealed. All of that should be done, but that requires more funding in the scientific process.
Agreed.
And also bringing in the public.
Agreed.
Into this. I think, again, we actually started talking about this because so many of our friends in the social media realm and others said, oh, look at this. This is such a weakness of science. Look what happened again. Again, another fraud. I'm saying, if not science, then what? You have a system, and we have to improve the system, a system that's not reliant on power, on finances and things of that nature, but there are some flaws that we should address. Again, reproducibility is important, and validity is important, and making sure that there are a lot of eyeballs on the data, that's important. And the other thing is, don't put all your eggs in one basket. When you're looking at a disease as massive as Alzheimer's, and you've gone at it for decade after decade with failure after failure. 400 mouse models succeeded. Everything that you could think of worked on mouse models, but and they were all amyloid models.
Yeah.
But when it came to humans, they all failed. There should be a reassessment that maybe we should actually approach things in multiple different directions, just for the sake of even mechanistic approach being better elucidated.
Right.
and not just myopic, linear, all eggs in one basket science that has failed us over and over again. So it's a concept that actually put us on our heels. We were thrown off by how, if this turns out to be true, how devastating this was for the last 2 decades and all the millions of dollars that was spent in the wrong direction. And we see the outcome of that.
Right.
We see the Alzheimer's patients that come to us day in and day out where we have no medication, no treatment. And by the way, these patients, we had our own grandparents who are these kind of patients, then become desperate and they're open to abuse by charlatans that sell them vitamin concoctions.
Right.
So instead of that, if we would actually focus on prevention and other pathways as well, it would be wonderful, and work on systems that are more transparent, more validated.
Beautifully stated. So what's next? So immediately, what are some of the damages that have been done based on what we're seeing right now, Dean?
Millions of dollars wasted if this is true. Again, we keep saying that it has not been fully corroborated that it was a fabrication. We still don't have the raw data. The final, conclusion has not been made as far as whether it was a fabrication, but there seems to be strong indications that it was. If true, it was a devastating loss of time.
Right. And also, time and money. You're absolutely right. And like you said, scientists, when they get to that field, obviously the system is arranged in a way where, you have mentors and you essentially kind of continue your mentor's work as well. So there's been a myopic approach to Alzheimer's disease. And I think you and I have been talking about this for many, many years. And what would be some of the things that you would like to see for neurologists and neuroscientists learning from this issue?
Question the data. One other thing that stands out of this is Matthew, Dr. Schregg. When we were at Loma Linda, he was working with a friend of ours, a neurosurgeon, who was working at the iron model of
the iron metabolism,
iron
metabolism. Deposition.
Yeah, exactly, iron deposition. Schregg's particular area of research was that iron deposition in the brain, as well as other metals and other things as well. But that was the main thing, and I believe that was his thesis, his research.
Yes,
a PhD thesis, and it was beautiful. He actually found nothing. His conclusion was that there was no evidence that iron was a cause for Alzheimer's. And I remember one of the conversation, because he was so incredulous, he questioned the things that were in front of him. One of the things that I learned from him, and I was a senior of his, was that when you look at even meta-analysis, you're looking at data there's a bias in the data. There's a negative publication bias, meaning that if there's negative results, it doesn't get published. So things that get published are usually positive results. So you have a whole set of the left side of the curve. I'm using that as a metaphoric way, but actually it's in statistics, the left side of the curve. You're missing all the data that was negative. So all you're seeing is the positive data. So the same thing happened with iron deposition. All these papers that showed some correlation between iron and Alzheimer's, but none of the papers that were negative were ever published until you actually go to the science, go to clinicaltrials.gov, look in the past, do some analysis. If anybody put in other research proposals about iron and they never published, and then you talk to the scientists and say, oh yeah, the result was negative, so we didn't publish. Why wouldn't you publish a negative result? Because it's not as interesting, it's not as sexy, so the journals won't publish them. That's a flaw right there.
Right.
The journals should have as much interest in publishing negative results as positive results. So even this, if you listen to some talk shows, they talk about meta-analysis and clinical trials and all of this, but not recognizing that even there's potential for flaw.
Right.
There's a positive result, a bias that pushes meta-analysis often falsely. So you say false positive results toward a direction that might not be the case, because all you saw was the positive results. All the negative results were never published. So we have to have a better look at the data. both positive and negative. There should be some incentive for journals publishing negative results as well. There should be an incentivization for openness of data to the general public, especially now with social media, with systems that actually can bring eyes of millions of people onto the data. Maybe even better systems of interpreting data, where a lot of the hard work that people might not be interested in is done for them with AI and machine learning. And then here's the result. And so millions of people can look at the positive and negative results, do their own analysis. So let's fix the system. Let's use this occasion, if true or otherwise, even if it's not true, to reassess how we look at the data, how we validate data, how we come up with conclusions, how then we fund research. And is it just in one direction? Or even if there's strong evidence in one direction, we should actually invest in alternative pathways as well, so that maybe we can actually have a picture of mechanistic approaches other than the one that's being taking over the consciousness of researchers. This is an important time in research in Alzheimer's, but in research in general. Keep your eyes open. Keep a lookout for how this story turns out. We'll keep you updated. And this was definitely one of those investigations that interested us.
Thank you so much for your time.